Okay, so today we're going to do 3.8, which is point slope form. First thing, make sure that you do the daily review. So for A, B, and C, you have an x value of -4 and a y value of -2. So make sure that you substitute them in for x and y, and then simplify until you have one single constant. For D, because we have absolute value, you will need 2 answers to this equation. There are 2 values of x that make this equation true. And then E is just a normal equation. Use a distributive property and solve for x. So again, this is 3.8, which is point slope form. This is a form of a line, which we'll look at. And then just as a quick review, we also did slope intercept. Form. So slope intercept form, if you recall, is y equals mx plus b, where m is our slope and b is our y intercept, which is why it's called slope intercept form. From the equation, we can quickly grab our slope and our intercept. So in our point slope form equation, we'll be able to grab our point. So a point to start from, which is not the y-intercept. And we'll also be able to grab our slope very easily. So here's example 1. This is really the start of it. With all of these, you're going to start at your point. So we start at our point, which is at 0, -3. So we plot that. And then we're going to use our slope, which in this case is 2. So our rise is 2. And our run is 1. So up 2 over 1, up 2 over 1, all the way across the graph. And you have your line. And then similar with the other ones, just different slopes, different points to start from. So in number 2, we're going to start at the point -4, -3. So there's -4, -3. And then we're going to go up 3 and over 5. And up 3 and over 5. And then we can go down 3 and left 5 as well, just to continue across the graph. 2, 3, 5. So your line for number 2 is going to look like this. Three, again, very, very similar, a different point, and we have a negative slope. So your line should be decreasing from left to right. So we start at 3, -1. So here's 3, -1. And then our slope is down 1 and then right 3. So from this point, we're going to go down 1 and then to the right 3. And then we can go backwards, so up 1 and then left 3 to continue our graph all the way across, or to continue our line all the way across the graph. So make sure that you do number 4. So graph it correctly, plot the point, use a slope, and graph your line through the point -2, 6 with a slope of -4. Okay, at the end of this, you'll have the 3.8 activity. We'll go through one example with that, and then you will need to finish the rest of it correctly also in order to get full credit for today's work. And again, here's point slope form. So the first thing we have is our point. So x1, y1 is just going to give us a point on the line. And you can see that x1 is right here. And y1 is right here. And notice these signs also. So this means the opposite. Because they're both minus, they're going to be the opposites. So x1, y1 is a point on the line. And m is our slope. So you can still find m pretty easily. It's going to be your coefficient of x when you have parentheses in slope-intercept form, or in point-slope form. It's the number that's right outside of the parentheses. So I'll give you 3 quick little examples. Y minus 2 equals 3/5 times x minus 1. So our point is going to be the opposite of this number because the x is first in an ordered pair. So the opposite of -1 is +1. And then the opposite of this number with y, that's on the same side as y. So opposite of -2 is going to be +2. So our point is 1, 2. And then our slope is 3/5. So once we have this, we're essentially back to what we just did with example 1. We have our point and we have our slope. And then we can graph our line very, very quickly. Here's another example. Let's say we have y plus 3 equals negative x plus 5. So again, we can get our point, which is going to be the opposite of what's with x, in the parentheses with x, which would be -5, and then the opposite of what's with y, which is going to give us -3. And then our slope again. So in this case, if we just have a negative sign, that means there's a -1 here. So our slope is going to be -1. And then to use that, we would go down 1, right 1, in order to graph our line. And then sometimes things might be missing. So for instance, so if we have an equation that looks like this, there's nothing that is added or subtracted to x, which gives us the x-coordinate of our point. So in this case, if there's nothing added or subtracted, then it's going to be a 0. With multiplication, if there's nothing there, it's a 1. With addition and subtraction, if there's nothing, it's a 0. And then the opposite of what's with y, which is going to give us +5. And again, the slope, real easy to figure out. In this case, it's going to be 3/5 again. So again, we have our point, we have our slope, we can graph our line very, very quickly. So here's example 2. We're going to go through and find the point for each one of these first, and then we'll do the slope, and then we'll graph them. So we want the point for 1, 3, and 4, and then you're going to do 2 on your own. So attention to detail is really important. It's the opposite of what's with x, which is 1, and the opposite of what's with y, so the opposite of -5 is +5. And then in 3, our point is the opposite of +1, which is -1, and the opposite of +3, which is -3. And then 4, the opposite of +4, which is -4, and the opposite of -2, which is, just +2. And then for each one of these, we need the slope. So in the first one, our slope is just in front of the parentheses, which is the number 3. We can use that as 3/1. In number 3, again in front of the parentheses, so we have 3/4. And then in front of the parentheses for number 4, we have -0.5, which is much easier to use as a fraction because we can go down 1 and over 2. All right, so then we can graph each one of these lines once they're similar to example 1. So our point's at 1, 5. And we're going to use a slope of +3. So from that point, we go up 3 and over 1. And your line is going to look like this. So all of these points are going to be on that line. And then number 3, so again, it's almost exactly like example 1. We started our point -1, -3, which would be here. And then we're going up 3 and over 4. Well, it's -2, -3. Hang on. -1, -3 is here. So we're going to go up 3 and over 4. And up 3 and over 1, 2, 3, 4. And then down 3 and left 1, 2, 3, 4. And then down 3, 1, 2, 3, 4. So there is your line for number 3. And again, really, really simple because we found the point and we found the slope. So -4, +2 is here. And the slope of -1/2, so we're going to go down 1 and over 2. All the way across your graph. And there is number 4. So that's graphing from point slope form. Example 3 I'm going to kind of explain, and then you can finish on your own. So notice the directions. They say graph each line on the same graph, and you have this graph right here to do that. So the first line that we have y equals 1/2 x minus 2. So this is an input-output table. So you're going to do 1/2 times -4 minus 2, and that's going to give you your y value. And then you're going to do 1/2 times -2 minus 2, and that's going to give you your y value. So it's back to what we did in 3.2. So continue that. Figure out the output when you plug in 0 for x. And then figure out the output when you plug in 2 for x. And then plot the points. And connect. So that was the first way we learned to graph lines. The next one, so this line is in slope-intercept form. We have y equals mx plus b. So you're going to figure out the y-intercept, and you're going to figure out the slope, and you're going to plot the y-intercept and then use the slope to graph more points on the graph. And then 3 is what we just did today. So this is in point slope form. Notice the difference between these two equations. This one has y plus, y is not isolated in this case. We have y plus or minus something. So figure out what your point's going to be, and then figure out what the slope is. And again, graph this on the same line. So you should have all 3 of those equations on the same graph, which is right there. Okay, and then that brings us to 3.8 activity. So it says complete each chart and graph the lines. Find the slope of the line that you graphed. So this is an input-output table. It just looks a little bit more complicated than our slope-intercept form equations. So we're going to plug in -7 for x. So we have y minus 2 equals 3/4 times -7 plus 3. So order of operations, we have to do -7 plus 3 first, which is -4. And then -4 times 3/4 is going to be -3. And we have to solve this equation for y, so we have to get rid of this minus 2 by adding 2 to both sides. So we have y equals -1. So we have an x value of -7, and we have a y value of -1, and that's going to be a point on our graph. So we can go ahead and plot that, I guess. -7, -1. So there's our first point. And then the next one's similar, except instead of plugging in -7, we're plugging in -3. So we have y minus 2 equals 3/4 times -3 plus 3. Well, this is nice because -3 plus 3 is 0. And then 0 times 3/4 is 0. So we have y minus 2 equals 0. And then to solve this, we can add 2 to both sides. So y would equal 2. So our point then is at -3, 2. And we can put that on our graph. And then last but not least for this one, we're plugging in 1. So y minus 2 equals 3/4 times 1 plus 3. So 1 plus 3 is 4, and 3/4 of 4 is 3. So y minus 2 equals 3, and then add 2 to both sides again to finish this one off. And we get y equals 5. So our ordered pair is at 1, 5. So here's 1, 5. You can see these are all on a straight line. Every graph in this unit should be on a straight line because we have linear equations. So if you're not getting straight lines, then you're doing something incorrectly. And then the question also says, what is the slope of this line? So we can take any 2 points and find the slope. So we're going up 3 units. And then we're going to the right, which is also positive, 4 units. So the slope of this line is going to be 3/4. And you can get that from our point slope form equation as well. So a slope of 3/4, and then you can see that on the graph. So make sure that you finish 2 through 8 for this activity. And then answer this question here that says, compare the slope of the graph of the line to the equation and the points in the equation. What do you notice? And you should notice what we just talked about with point slope form. So as always, let me know if you have any questions.